Hi everybody, today we're going to have a look at some different types of graphs. We're going to start with a planar graph. Now in this first case, this is not a planar graph because the edges cross at a point where there's no node. But we could make it planar by taking this edge here and drawing it around the outside, as I've done here, and we can make a not planar graph into a planar graph. Now the interesting thing about planar graphs is if you can draw them, then they will always satisfy Euler's rule. Euler's rule says that the vertices plus the faces is always equal to the edges plus 2. So in our case here, if we just look at the left-hand side, the left-hand side would be 4 plus 4, which is 8. And the right-hand side would be 6 plus 2, which is also 8. So because these numbers agree, we have a planar graph. And it's one way of proving whether a graph is planar or not. So there's our first definition, planar graphs. Second one, what's a cycle? What's a tree? A tree is anything that doesn't cycle. So with this graph here, it cycles in two different ways. I could go from this one back to the same node. Therefore, it'd be a very short path, but it would be a path. Or I could go from here back to here. That would also be a path because I'm not repeating any edges or nodes, and I can get back to the original node. So any connected simple path, simple graph, like where I can create a closed path or a cycle, is called a tree. Now here's a tree. I can get to every node on here, but there is no way to create a closed path because every time I will end up at a position where I would have to repeat a node or an edge to get back to where I started. Okay, a subgraph is a selection of nodes or vertices from another graph. So here's our graph, and I've taken out the D, A, and B, and I've redrawn it over here. This is a subgraph of our original graph. That's quite easy. Now, the only really difficult one is the bipartite graph. Now, a bipartite graph has two groups of vertices, and the nodes in the new graph cannot have any connecting edges within each group. So, sounds complicated. Let's look at this very simple case. I've got a graph A, B, C, D, and I want to know if I can make it into a bipartite graph. What I've done is I've grouped A and D on one side and B and C on the other side. And then I've drawn in all of the edges. And you can see here that A and D are not connected directly, and B and C are not connected directly, which is the criteria for a bipartite graph. And we've got connections, but we can have connections between the two groups. So between B and C, no edges connect. Between A and D, no edges connect. So that's one group, that's the other group. And then I can draw in all the other edges. We've split the nodes into two groups. Now, for a more complicated case, you might, like this one here, you might think that's quite difficult. But what we can do is identify adjacent nodes, and that will make our life a bit easier. So to do this, we start at A, and then we identify the adjacent nodes to A. And then we go to C, and we identify the adjacent nodes to C the same way. So you always have one not colored in, one colored in, one not colored in, then connect all the ones up that are adjacent to it. And then do the same thing, go to the next one that's not colored, make sure they're colored, go to the next one that's not colored, make sure. If you can do that, and then redraw it, so I'm going to put all the non-colored ones on one side. So A, C, D, and F. And I'll put all the colored ones on the other side, B, E, and G. And then if I draw all the edges in from this graph, I should get a bipartite graph if it's bipartite. So A connects to B, A connects to E. Let's draw these nodes in to make our lives a bit easier. A connects to E. All right, B connects to A. We've already got that one. And B connects to C. So I'll draw that one in. C connects to B. We've already got that one. C connects to G. So we'll draw that one in. And C connects to E. G connects to C. We've already got that one. G connects to F. and that's all that connects to G. We could do E. E connects to F. E connects to A. We've already got that one. E connects to D. 1, 2, 3, 4. 1, 2, 3, 4. That's good. And then D connects to B and E. So there. Now we should see that if we compare this graph to this one, the nodes all connect in the same way. A is connected to B by these two edges, and A's got two edges over here. But now A, C, D, and F, there's no direct link between D and F, C and D, A and C. They're not adjacent in any way. And the same with B, E, and G. They're not adjacent in any way. And because we've now managed to put them into two groups, B, E, and G, and A, C, D, and F, they are bipartite graphs. So there you go. 4 things that you need to know. Planar, with Euler's rule, what's a tree, what's a subgraph, and what's a bipartite graph. I hope that was helpful, and I'll see you in the next one. Thank you, everybody.